Here are some tips for balancing chemical equations. First, balance pure elements last. Second, when no pure elements are present, balance simple species like H2O last. Third, when present, balance polyatomic ions, not atoms. Let's look at a few examples of each. In an earlier video, I showed the reaction of methane with oxygen to yield carbon dioxide and water. Here, the carbon is balanced, but the hydrogen and oxygen are not. Notice that oxygen on the reactant side is in its elemental form. In other words, oxygen atoms are not bonded to anything else. Only oxygen, O2, is present. Let's balance the O2 last. In this example, since the carbon is already balanced, we can balance hydrogen first. A coefficient of 2 in front of water means you multiply water by 2. There are 2 water molecules. This balances the hydrogen. But the moles of oxygen has changed. There are now 4 moles of oxygen on the product side. We can balance the moles of oxygen on the reactant side by inserting a coefficient of 2 in front of the oxygen. All of the elements are now balanced. Notice there is no need to write coefficients of 1. If no coefficient is present, a 1 is understood. Here is another example of balancing oxygen last. Ethane, C2H6, reacts with oxygen to yield carbon dioxide and water. Similarly, we see that oxygen is in its elemental form. We can balance oxygen last. I'll balance the carbon first by inserting a coefficient of 2 in front of carbon dioxide to balance the carbon. Next, insert a coefficient of 3 in front of water to balance the hydrogen. The carbon and the hydrogen are now balanced. We can balance oxygen next. Notice on the product side, there are 2 carbon dioxides, each having 2 oxygens. This means that there are 4 oxygens from the CO2. There are 3 waters, each having 1 oxygen. This means there are 3 oxygens from the water. There are 7 oxygens total on the product side. There are 2 oxygens on the reactant side. This is why we save the pure element for the end. We can always insert a coefficient in order to balance the equation. In this case, we need 7 oxygens on the reactant side. 3.5 or 7/2 will give us 7 oxygens. Notice there's a fraction as a coefficient. It is customary in general chemistry to report coefficients as whole numbers, so we can multiply all coefficients by a constant to get a whole number. In this example, we'll multiply all coefficients by 2 to get a whole number. The equation is now balanced with whole numbers. Let's consider another example where there aren't pure elements present. Here we see the example of iron 3 oxide reacting with nitric acid to yield iron 3 nitrate and water. There aren't pure elements present, but we see a water, and I'll balance water last. Another thing you'll notice is that there's oxygen everywhere. Trying to balance an element that appears all over the place can lead to confusion and headaches. I do see, however, there is a polyatomic ion, nitrate, present on both sides of the yield sign. I can balance the nitrate ions instead of the oxygen atoms individually. I'll start by inserting a coefficient of 2 in front of the iron 3 nitrate to balance the iron. Next, I'll balance the nitrates by adding a coefficient of 6 in front of nitric acid. The iron and nitrate are now balanced. The only thing left is to balance the hydrogen and oxygen in water. A coefficient of 3 will do that for me. The equation is now balanced. Let's recap. First, balance pure elements last. When no pure elements are present, balance the simple species, like water, last. When present, balance the polyatomic ions, not the individual atoms. For first-year chemistry students, it is likely you'll find yourself in a loop at times. If you ever find yourself going in circles, stop, take a breath, and start from the beginning. Having a slice of pizza and ice cream might help too.